Hey, what's going on, guys? In this video we are going to see how to prove this proposition using Archimedean properties. Here we have the proposition says for all x belongs to a real number if for all n belongs to a natural number x is less than or equal to 3 plus 1 over n, then x is less than or equal to 3. Now if we write the contraposition for this one, the contraposition is basically we negate both of them and flip this one. So when we do the contraposition, it's going to be for all x belongs to real number, the first one remains the same. If after that we have to write the negation of this one, the one comes after, then if we write the negation of this one, this is going to be x is greater than 3, x is greater than 3, and then we have to negate this one, this is going to come after. Then for all n belongs to a real natural number will become there exists and n belongs to natural number, because for all n negation is there exists. So there exists and n belongs to a natural number, and the negation of this one is going to be x is greater than 3 plus 1 over n. Okay, when we do the contraposition and the original statement always the same meaning, right? If you prove the contraposition right, it means we prove the statement is right. Now let's go ahead and try to prove this one. So here we are going to use the Archimedean property. Now let's see what the Archimedean property is. Archimedean property says when we have a, so first we have to say for all a comma b belongs to a real number. So when we have an a, if a belongs to, like if a is a natural number greater than 0, then there exists an n belongs to natural number such that na is greater than b. So we are going to use that one to this one, because here we can use this statement, because like when we do the contraposition, this is our claim, this is what we want to prove, claim. So we have to use this one to prove this one. Here we have x is greater than 3. Now we have to solve an a that is greater than 0. So this is, if you rearrange this one, this is going to be x minus 3 is greater than 0. Okay, now we have an a, this is our a. Now to find out the b, we can use this one right now. So x minus 3 times n is greater than 1 if you rearrange this one. So this is our, you can compare with this one, this is our a value, this is our b value, right? Now we just have to prove this statement. So we have, so if x minus 3 is an a, this is a greater than 0, so it says the Archimedean says there exists an n belongs to a natural number such that na is greater than b. So this is true. Now we have to bring this one back and say this one also true. So to bring this one back, what you can do, you can move this one to this side. X minus 3 is greater than 1 over n, and we add 3 to both sides. If we add 3 to both sides by additive inverse, negative 3 and 3 becomes 0. So you will get x that's greater than 1 over n plus 3. We are adding 3 to both sides. So negative 3 plus 3 becomes 0 by additive inverse, or axiom number 4. If you want to know the axioms, I made a video on that. I put the link of the video in the description, so you can go ahead and watch them. So by axiom number 4, minus 3 plus 3 becomes 0. In the other side we have 1 over n plus 3. So by that we can say there exists an n belongs to a natural number such that x is greater than 3 plus 1 over n. So we proved this statement, right? We proved this one, we proved the claim. If we prove the claim of contraposition, it automatically means the statement also true. And that's how we do the proof question using Archimedean properties. I hope this helps. Thanks for watching. And if you are trying to learn discrete mathematics, there are a bunch of videos in my playlist, and there are a bunch of proof questions in playlist too. Don't forget to watch them, don't forget to subscribe, and if you have any question, put it in the comments, so I will try to answer as soon as possible. See you next time.